Good afternoon, everyone, and welcome to our virtual tour of outer space. My name is Josh. I am sending out our content this afternoon, not from my house, which is a very exciting thing for me, probably my wife too, but we are sending out from the California Academy of Sciences. We are in the process of reopening for the public. We are welcoming our members back this week, but next week, I think on the 23rd, we are open to the general public. We are so excited to see people back in the museum. But before our dome opens up, we're going to continue to do all of our digital content, and we are excited to be bringing you this week our virtual tour of outer space in our software, as usual, OpenSpace. So if you are a passionate space explorer like I am and you want to do some flying from your home computer, you can download OpenSpace at the openspaceproject.com, and you can do basically the exact same tour I'm doing, but I'm using my computer at work, which hasn't been updated in a little while, we discovered. So 6 months ago, there was a couple things a little different in OpenSpace, and if you download a brand new version, you will have everything up to date and wonderful working. Things are going to get a little funky at some points, but there is some exciting news. Because I'm using our work computers and they have very fancy maps built into them, I can show you some of the objects I've been promising to show you and failing to show you for weeks. So I hope Sam is watching. I hate to have broken your heart so many times before. There are lots of cool things to see. So when you are checking out our OpenSpace broadcast, we hope at the very end you can follow our SurveyMonkey link and do a quick survey, just a couple minutes, and let us know what you think of the program and the software. The first 30 respondents get a super cool NASA meatball sticker, and that offers winding down, I believe. So if you wanted to get one of those stickers, you keep thinking, one day I'm going to fill out that survey. Now is the time to do it. Fill it out. Let us know what you think. We are delighted to hear from you. So with that, we can check out our software a little closer up. We are starting at Saturn. Now, Saturn is absolutely beautiful. Great thing to check out. You can see those wonderful rings. I'm going to show you how long it's been since I updated my software. Check this out. Notice something kind of funny about Saturn? I'm not going to tell you, at least not for a moment. We'll fly around for a minute. If you've been watching these broadcasts, you'll notice something is different about Saturn. Check out the rings. Now, previously, when we've looked at those rings, you can see something a little interesting. Now, when we had Micah on for one of our cosmic conversations, he pointed out the difficult programming that went into creating a shadow from Saturn falling on the rings themselves, as well as the shadow of the rings falling on Saturn. This is right before they implemented that change to the software, so Saturn's rings don't have a shadow on them. Pretty minor, all things considered, but kind of a cool detail. Interesting thing to see how this map of the universe, this software that lets us fly, has changed over time. Now, when you look at those rings, you can see right along that razor thin edge, there's actually two little gray balls hanging out next to us. Those are two of Saturn's moons. A lot of Saturn's moons hang out right on the exact same plane as the rings themselves. It's around the equator of Saturn. Now, one of those gray balls is a moon that I don't have mapped surface for. But the other one, oh boy, the other one is not just a gray ball, even though it kind of looks like it. It's the moon Enceladus. Many of you have been asking for weeks, nay months, for a up-close and in-person view of Enceladus. And I kept saying, oh yeah, I'm going to fix it. I'm going to fix it. Our engineer told me that it runs well on our Academy computers because they are relatively robust. My home computer is not so robust. So now I can finally show you Enceladus. Now, you can see some of these super cool features up close and personal, but I want to show you all of Enceladus. So we're actually going to turn nighttime off and let the entire surface be illuminated. Check this out. Down here, you have an amazing group of features which are called the tiger stripes. These are not any color tiger I've ever seen. They're white and blue. I don't think there are tigers like that out in the world, but they are perpendicular stripe, I should say parallel stripes, with a perpendicular feature down here. These are windy, sinuous features that change. There's actually a color change as well on some of them. What we're seeing, we think, is weak spots where the surface of Enceladus keeps bending and changing because from time to time, we actually see material escape Enceladus, blast off into space, and give us a wonderful show. So to see that a little better, I'm going to put nighttime back on. I'm going to line us up out here. We can see that if you imagine Enceladus between us and the sun, material blasting off the surface of Enceladus out of those tiger stripes being illuminated by the sun, This was actually captured in a Cassini photo and let us see material escaping the surface of Enceladus, something absolutely beautiful and proof that there is water moving under the surface of this icy moon. That white stuff, that cracked surface is ice. It is solid ice. We can see it changing in some spots in some beautiful ways. You can see newer features overlaying older features. It is chaotic. It is wonderful. It is almost crater free, and that tells us it's a young surface. And I will say, if you love ice moons as much as I do, you are going to want to make time this Friday at 11:30. We are bringing in a specialist on Europa, which I think even with these views of Enceladus, this week I'm going to say Europa is still my favorite moon because I just learned so much about the surface of Europa practicing with our expert. If you like ice moons, do not miss this Friday at 11:30. It is going to be something special. Okay, so flying away from Europa, looking at that beautiful razor-thin ring structure around Saturn, any place else you folks want to visit, someplace in our software that you think would be super cool to see. If you've been flying around in OpenSpace and you've got a favorite location you want to show everyone else, let us know in the comments, and I would be happy to fly us out there. Now, I'm going to do a couple other called shots that I've been waiting for a long time to be able to see. Let's go into the outer part of the solar system and visit one of my other favorite moons. Let's go see if we can spot Triton. Now, to find Triton, we have to go to the planet Neptune. Neptune is this very bluish thing. When we get a little closer to Triton, you can start seeing something is weird. Did the computer break? Is something weird? You can see green. You can see dark green. You can see purple. You can see all sorts of strange stuff going on here. I am here to tell you that this is not a fancy false color or translated color image. This is the actual colors we see on Triton. Triton is what scientists like to call bananas. Now, looking around, I turned off nighttime so we can see the entire surface. If I were to tell you, in looking around at this weird mottled green, blue, and tan kind of khaki surface, focus on the cantaloupe terrain, would you be able to tell what I was talking about? Is there a part of this object that reads as cantaloupe to you? I would say this entire region looks like cantaloupe skin. That is extra wacky. This is a mysterious feature still. I don't know if there's a consensus on what makes the surface look like that, but it is very strange. You can see over here some spots that look a little bit like the surface of Pluto in terms of that glaciation, stuff moving around. Triton is probably a very close analog to Pluto, to the point where they might be objects that were born in the same way. I would spend a whole show on Triton, but it looks like we got some great comments coming in. If you want to check them out, I see Enrique was requesting Ceres. Let's see if we can make Ceres happen. So heading into Ceres, Ceres is closer to the sun than Neptune. Yep. I seem to have had an error with Ceres. Of course, it figures the things that I can easily target at home don't work here. The things that I can target here don't work at home. So let's see if I can get a Ceres. Doesn't seem to be loaded in this profile. I am so sorry, Enrique. I can show you Ceres next week. Okay. Haumea. Ooh, let's see. For some very distant objects, what have I got? Haumea. I don't think we have anything out that far, but let's try. We're going to zoom back a great distance from our solar system. Just when you thought Neptune was at a great distance, it ain't even close. Haumea is much farther away, and I'm not seeing anything turn on. And we probably should have seen it by now. Yeah, I'm going to go out on a limb and say Haumea is not loaded either. I did see a recommendation for Mars. Mars is loaded. I'm 99% sure Mars is loaded. Let's try this out. You can't have a solar system without Mars, right? Mars is 1/8 of the things that are going on, if not by volume for sure. By importance, it's probably 1/3 of the solar system. People love Mars. Okay, falling into that beautiful Martian surface, we can see all those great crater features. Looking around here, I keep hearing the words of all of our cosmic conversation experts telling us about all these amazing things we can pick out on the surface, but I'm left with what I love doing, which is plopping down on the surface of Mars as close as you want to get and just flying in a direction. There are so many cool things to see. And the longer you look, the more likely it becomes that you will see something you've never seen before and something maybe worth looking up. I can see these long straight lines. Those look like maybe some kind of faulting, a crack. There's so many of them parallel to each other. It must be some kind of unified feature. You can see a very chaotic area over here. It kind of looks like elephant skin. That's really cool. Again, I wish I could tell you more detail about these places, but the problem is that there's so much interesting about every single part of the Martian or any planetary surface that there's just always more stuff to look up. You can see these massive volcanoes. It means we're on the Tharsis Plain. These are some of the biggest volcanoes in the solar system and one of Mars's most exceptional features. Certainly the one people make the biggest deal of. I know we do here in the planetarium. There's good old Olympus Mons, biggest volcano in the solar system, and this huge plain around it. In this view, you can actually see right up here how big the shield of this volcano is. This is all a lava plain associated with that giant erupting center. That is pretty amazing. Okay, taking a big step back. Mars's moons, Phobos and Deimos. Let's see if we can pop them in. I can show you Phobos's orbit right there. And I can show you Deimos. Boom, just a little farther out. Now, here's a really cool thing. How long does it take our moon to go around planet Earth? 1 month. Very close to a month, actually a month. If we watch here, check it out. I'm going to go by, let's say, 60 seconds per second. That means a minute per second. And we can actually start to see the closer moon moving ever so slightly. If I go faster, let's see, how about, go back down to real time. Let's go about a hair short of 3 minutes a second. And now it's chugging across the sky. Okay, jumping back to real time. Let's go forward by an hour, okay? In 1 hour, boom, good chunk of the arc has been completed. In fact, we will see that inner moon, Phobos, go all the way around in, I think, about 8 hours. That's incredible. So imagine if the moon made its way all the way across the sky and back to the same spot in 8 hours. So months on Mars, if you have months, they'd only be 8 hours long, and that makes things really weird. If I say, oh, I'll pay rent next month, that's in 8 hours. So we can see the orbits very clearly for these things, but let's see if we can do a little better and actually go visit the objects themselves. Phobos especially is super interesting to see. So as I dive in, the first thing you might notice, I want you to pick out, is the shape. Now, when you look at this moon, fundamentally, it does not look like our moon. It has craters, sure. It's got a gray rocky surface. Okay, it's got lighter and darker regions, sure. What makes it so different from our moon? Shape. And it turns out shape is very illustrative. When you look at the shape of this moon, you can instantly tell it is small. How can you tell that from the shape? There are big things, there are round, small things, not necessarily shape differentiated. But in space, the bigger something is, the more likely it is to be round. When you've got a small rocky object like this that isn't quite round at all, you really get a perspective on how small it is. This thing never had enough mass, enough structure pulling itself in to crush itself into a roundish shape, a process we call hydrostatic equilibrium. Now, this thing stayed irregular, and that puts it in the category of object we often associate with the asteroid belt. We call these things space potatoes. Not because they are potatoes in any way, but they kind of look like them. A lumpy, bumpy, grayish-brown object floating in space. It's a space potato. Okay. I love Phobos. It is such a cool place. Ooh, more requests for series. Alas, I keep hitting the series button and nothing happens. I'm very sorry. You people have wonderful ability to pick out the thing that's just not working that day. Let's see. So let's take a big step back from here and go see if there's other things hanging out that I've not been able to show you before that would be fun to see. Taking a big step back, let's try out space. That's an easy one. Gaynor, you've got great ideas. Looking out from Mars, you can see two objects we don't often get to see in our part of the world, in the Bay Area. You can see the large and small Magellanic clouds. Now, you might be able to pick those out just on your monitor without any assistance from me. There's the large one. There's the small one. Now, these are our dwarf galaxies actually orbiting the Milky Way. These dwarf galaxies are much, much smaller, by like a factor of 1,000 than the Milky Way. They seem to be trapped in our own gravitational well. They're spinning around us. Okay, zooming back. There are some people who speculate they might be material from a previously eaten galaxy, but I think that idea has fallen out of vogue. We've been spending a lot of time at the museum today telling people about constellations that we see, specifically this guy here. So this is Orion. You can see those 3 stars for the belt and how they change with perspective. The farther away you get, those stars will be some of the last to move because they are the farthest away. But amongst the other stars, I believe this one is closest. This one's second closest. So we should see them move first. As we take this giant zoom backwards, there we go. So of the major stars of Orion, you can see the closest one right there. The second closest is Betelgeuse. It is a super cool thing. Now, zooming in, let's see if we can't peg where in the sky our Magellanic Clouds are. I believe they fall relatively close to Centaurus, but that would be a great question for Bing, who's being my producer right now, and he knows the night sky like the back of his hand. Okay, so let's dial back in, face back in that direction. So I will confess, the southern sky is something that I find absolutely amazing, but I have only had the opportunity to see it once in my life. So we had a trip down to Chile. It was beautiful. The night skies of Chile are spectacular. And if you want to pick out some cool stuff to see, that is the place to do it. We can see in the direction of the center of our Milky Way, we have Sagittarius, we have Scorpius. From our perspective, but if you look at this entire region of the southern sky that we just really don't get to see, right around the Southern Cross, which is right here, this is part that us Northern Hemisphere folk are woefully underexposed to. So if you want to do more searching on the Magellanic Clouds, looks like we dropped some links in the chat. Check them out and let us know next week if there are more things you want to know. We can prep assets and figure out maybe even a visit to some of these most distant objects. Okay, taking more big steps backwards. Let's see if there are other cool things to check out. I have a moon that was requested, I remember, a long time ago, and one that I would love to visit. This is Iapetus. Now, Iapetus and I think Mimas are some of the most famous other moons of Saturn. This one is our dichotomous moon. We've got one light side, one dark side. It is beautiful to check out. Huge cliff structures and a lot of very strange material. If I recall correctly, we now think that the dark stuff was deposited on a lighter surface because it's trailing into a huge amount of dust and debris in the Saturn system, and it's collected all that dust on one part of its surface. Some people call it like a yin-yang moon because it's got light and dark patches interlaced with each other. It is a really cool surface, though, so Iapetus is worth looking into some more. Ooh, we've got another moon request. Twist my arm. I will always take a trip to Ganymede. So heading out to Ganymede, this is a planet only because humans have, or excuse me, a moon only because humans have kind of a wacky system of deciding what a planet is. If we had a better system, I really think we would be calling Ganymede a planet. Ganymede is the biggest moon in our solar system. It's also orbiting the biggest planet, which is Jupiter. There's also, oh, there we go. When you look at the surface of Ganymede, it might look a little like Iapetus. It might look a little bit like some of the other major moons of our solar system. But compare it to Phobos for a second. Now, when you look at this surface, what is different than Phobos? It's got a dark color. It's even kind of a similar color, reddish brown. It's got light patches. It's got dark patches. It's got craters. Roundness. Phobos is a teeny tiny moon. This is a gigantic moon. And because of that, it is pretty much perfectly round. You can see some of those stress features on the surface, places where material seems to have moved. You can see a ton of craters all over the place, a very ancient surface to be sure. Callisto as well, tons and tons of craters. Now, we're going to visit some of the other Jovian moons in our talk this Friday. I'm sorry to keep plugging it. I'm just so excited. And you get to see the contrast between an ancient surface like this and a very fresh, brand new surface like Europa. It is a beautiful place and a really cool thing to see. Now, we got some folks tuning in from Chile. Oh, I am so jealous. The night sky is something truly special. And we visited some kids in Chile who've grown up under those stars. And I tried to impress upon them how wonderful it is to be able to see that. And I really want them to talk to kids who live in San Francisco who have never seen more than 20 stars on any given night, which is, to me, a little depressing. Let's see. We've got an opportunity while I'm waiting for our next request. We've got about 5-10 minutes left. So if you got something else, throw it in the chat. But I'm going to head us into a part that we really haven't visited at all so far today. And that is our very own planet Earth. Looking down here, you can see our sky at night because we are not showing exactly the time right now because I was playing around at Mars. So right now, North America is completely in shadow. You can see the lights of the West Coast over here, the lights of the East Coast over here, our friends in New York, in that very bright city. If we head down to Chile, you can see there are a couple concentrated spots of light around some of the major cities, but especially around the Andes, you get very little light. And that's one of the reasons we are so excited to put in our new telescopes in Chile. Give us a chance to really take advantage of some of those dark skies, as well as the high elevation. I hope you folks can tune in and check out our show, Big Astronomy on Wednesdays, where you can find out about all the reasons the telescopes of Chile are so incredibly special. Ooh, we got a request to see the Big Dipper. Now, I can find the Big Dipper. That's something that I feel 100% capable of doing because, well, the Big Dipper is an easy one to spot. So when we look over here, you can actually see it hanging out behind Earth. How do I find it so easily? Well, on Earth, you just got to find Antarctica. Because if you can find Antarctica, that means the North Pole is pointed pretty much straight towards this star right here. That's Polaris. That's the North Star. Right next to it, you can see our Little Dipper coming in right here, the 4 stars that make the cup, and then the stars of the handle right there. If I tilt this down, you can see the Big Dipper interlaced with it. So 4 stars for the cup, and the handle is right there. You can even see Mizar and Alcor. There's the horse and rider right there. 2 stars very close together in the sky, even though they seem to be very far apart in actual reality. Okay. Ooh, Neptune. We can take a trip back out there. So Neptune is another blue planet, but very different kind of blue than Earth. When you look at Earth, there are some spots in our very deepest oceans that seem to have that rich blue, almost purpley color. Neptune has that all over the place. This beautiful rich color, we think, is a result of complex chemistry in its outer atmosphere. However, we don't know much about what's going on inside Neptune. There's a lot of speculation, a lot of modeling, but we need to do a lot of lab work, maybe some more missions to Neptune before we really have a concrete understanding of exactly what's happening inside this beautiful planet. So what we can tell from the surface, that dark color is true to form. It's not false. It's not translated. It's just the color we would see. You can see light clouds. You can see dark clouds. The surface is changing. Not quite as fast as Jupiter, but it does still change. We've seen persistent dark spots for decades. To answer Rebecca's question just popped up, Neptune does have rings, but in this version of OpenSpace especially, I can't show them to you. They would be around the equator of the planet. So just like we saw the rings of Saturn, imagine very slight rings stretched around the equator of Neptune right here. So right where those bands are at the absolute longest, that would be the equator. Okay. We've got some really cool stuff to see. Pluto, speaking of cool things, this far from the sun, everything is chilly, and Pluto especially is a very cold object. So cold, in fact, that when we see the surface of Pluto, we can see water. That's pretty exciting, right? Having water on the surface of Pluto. Unfortunately, water this cold is ice, and ice is actually relatively common in our solar system. We see ice just about everywhere that it's possible for ice to exist. So finding ice on Pluto, not that exciting. What is exciting about the ice on Pluto is the variation we see. Some spots are very smooth, other parts are very bumpy, and we can actually see features that folks in Chile might be familiar with called penitents or dragon teeth, which are sculpted from ice. At low pressure environments, when sunlight shines on the ice, it goes through a process called sublimation. Now, sublimation is different than evaporation. Evaporation is where water gets blasted off, turns into a gas, and leaves the surface. Sublimation is going straight from a solid to a gas. Evaporation is from a liquid to a gas. It's also different than melting, where you go from a solid to a liquid. So sublimation is basically the solid material just going away. You can see some of these cool blade-like features extending off the surface of Pluto. That's evidence of this process happening. If you want to see up-close photos, we haven't dropped anything onto the surface of Pluto, but you can see photos people have taken from the very top of tall mountains like the Andes and the Himalayas. I think even some mountains like Kilimanjaro, you can see some of that process happening. Depends probably on time of year, the amount of sunlight. There's a lot of variables, but they are strange, distinctive features to be sure, and really cool that we can see a similar process happening here. So looking around on Pluto, I want to show you one last amazing feature. You can see it right here. This kind of looks like what we saw on Triton. Some of those weirdly smooth areas on Triton. This is one on Pluto. This is our nitrogen pond, let's call it. Not quite an ocean. It's too sludgy for that. But in Golden Gate Park, I've seen some pretty sludgy ponds. So let's call it a pond. Now, this is a thick, viscous material on the surface that we think is nitrogen. Nitrogen is what we're breathing in right now, so it's got to be really cold on Pluto to turn it into this sludgy material. So looking around here, you can see some of the spots, basically mountain peaks, that are being consumed by the sludgy material around them, washing right up to the sides, forming little island chains where there might have been a whole row of those penitent mountains before. Okay, so I think we are getting pretty close to time. Yes, indeed we are. I'm going to start tilting us back in, but I'm happy to answer any questions along the way. I would also like to point you back towards that survey. If any of you had the opportunity, please fill it out. We would love to hear what you are thinking. The good folks at OpenSpace really appreciate your efforts to fill it out and let us know. On the way back, I would like to take a moment to introduce again some of the programs we'll be doing for the rest of the week. If you have younger viewers and you want to check out some space stuff, tune in on Tuesdays at 9:30. We've got a really cool broadcast then. Wednesday mornings, we are doing our show, which is Big Astronomy. You can check it out for yourself during the 11:30 time slot. And then, of course, on Wednesdays at 4:30, I get a chance to take you on our virtual tour of outer space and anything you are interested in checking out. Come tomorrow, Thursday, Bing's going to do a virtual night sky tour. So if there's anything you want to check out, tune into the night sky update. He can tell you about all the cool things to see in the upcoming astronomical hours of the night. And then on Fridays, we tune into our very special experts who can tell us about some of the cool things they are looking into out into the universe. And we get to tour again in OpenSpace, I think this week as well, checking out some of the surface locations on these distant objects with a real expert who can actually tell you what's going on, not just a passionate enthusiast like me. But with that, we have arrived back on our very own home planet. I would like to thank all of you for tuning in. We hope you can keep tuning into these virtual programs. We are always excited to see and hear so many comments and excited ideas in the chat. It makes my job a lot more fun. But from the California Academy of Sciences and Morrison Planetarium, thank you all for tuning in. We're excited to be reopening, and we cannot wait to see you in person as soon as you have the opportunity. Thank you for joining us for our virtual programs, and have a wonderful rest of your day.